Okay, next up is math. So these are some basic functions that are available with numbers. So we can do, order of operations are standard. So we do division before addition. We can use parentheses to control that as well, just like any other mathematical language. We can do math and then assign it to a variable. So there's a few different examples here. And then using our notation here, we can assign these numbers to different variables. So, or rather, sorry, we can print the values of these and showing how we showing their values. So A is 345, B is 6.0, C is this long number. So we're taking these values that we stored and then inserting them using this parenthetical notation. With numbers specifically, and this is where the standard notation here is desirable, is that you can format numbers different ways. So so here we have, and this also goes back to some of the Python 2 versus Python 3 stuff, but this is all Python 3 now. So when you divide when you divide integers, you're still going to get a decimal value, as you would expect. So although this is right, so here's what's happening here. So if we just evaluate d divided by e, so d is 1.0 and e is 4. So as we would expect, the value of this is 0.25. But when we're using this %d, this is a it's called a double, or basically an integer. So it's formatting this. What's happening here is we're taking d divided by e, which is 0.25, but we're formatting it as an integer. So when we do that, it gets rounded down to 0, and then that's the value that's printed in the string. So if we do %f, this will format it as a floating point value. So 0.250000. So this is interesting because it's actually adding more zeros than we really need, because the way that floating point values are stored internally is not absolutely precise. It uses a approximation to make the calculations faster, and sometimes you get slightly different calculations. So one thing we can do, if we want to round that down, say to 3 decimal places, we can do %.3, and this will give us 3 decimal places. If we want to see how it's stored in raw format, which is as it is up here as 0.25, we can do %r. And if we want to see it just formatted as a string, we can do, which is like what you'd get if you printed the value, which is similar to its value here. You can type %s. So in most cases, if you want to print the value of a number, you can use the string formatter %s. The reason you might want to use a different one would be if you say you wanted to control the number of decimal places that are printed, and there you could use this decimal floating point notation. So these are all string formatters. Okay. A little more math. We're going to do a couple more. We're going to import some packages. We haven't really done this yet, so these are built in, so that there's nothing we have to install. We can just type import math, and now we'll have access to the math package. So now these are functions that are available in the math module or math package. You can type math dot floor, and this will give us the round down a decimal or a floating point number, or ceiling will round up. We have something called factorial, so we can give it an integer and it'll give us the value of that value factorial. We can get the value of pi, square root, and we can combine these. We can calculate, we can set the value of pi to this thing we just call pi. We can set the square root to f, and then we can print the values of those using this string formatter.
Is there a way to get around having to write math dot all the time?
Yes, there is a way. If you want to, there's a couple options. You could, I mean, math is a pretty short word, but you could do import math as math, and then you could type, like we did that. Then you could do, for example, that's not really useful in this case. You can also type from math import all, and then you could do that. However, we tend to discourage you from doing things like this, because now you've got all these things from math in your namespace that you don't even know what's there. Let's say you wanted to, like, let's say you didn't know that floor was a thing, and then you're like, I want to say floor equals 6. And now if you try doing this, it doesn't work, because you just took a function and you named it something else. So the advantage of not doing this and instead doing this is that, yes, you have to type a few more letters, but you now have a little more, like, you're not clouding your namespace with all this extra stuff. Okay, there's another module called random that we'll quickly cover. So we can import random, and random has a function called random, which gives us a random number from 0 to 1. There's another function called choice, so we can give a list, and it will randomly choose from those choices. We can. Yes. Let's try this. So try that, and then see if you get the same answer. So set your seed to 42. Yeah, okay. So that's how you do it.
Will that just work for one?
I assume, well, we can try it. You're going to get a different answer the second time, but you should get the same. If you do it again, you should get the same. I know you can tell. You can tell me if you get.
It only works for one iteration, and it seems to go back to like a random seed. So I just like what you
Yeah.
said,
Yeah.
If I rerun the random seed 42 and then I do random, I get what we had before.
Yeah. I don't know. Sometimes they'll use. Yeah. I'm not sure.
So if he set the seed, hit random, he got the number, you got the same one. And then his second time,
Okay.
he didn't reset the seed.
Here.
You didn't reset the seed.
Here-
So you end up with the
Here's a way to find out. Here's a way to find out. Click, do this random choice one here, and go up to kernel, and go restart. Restart and clear output, and then you should still have this one selected, and go cell and run all above. now you should have, it should have chosen 1 here. And then we can do, and then, yeah? And then this one is 5 also, if you run that one next.
That one I get 1.
Does it say 70?
Oh, hang on.
So I think every time you run the random command, it's going to, that's going to use the next number. So if you, anyway, I do think it's deterministic once you set the seed. You guys are so interested in these seeds. I mean, it comes up, but like typically it doesn't matter. Like it's going to get.
I find that like sometimes if I'm trying to run.
Oh, I guess if you're doing a simulation, like you want to get the same result every time. Or,
If I'm,
yeah.
If I'm actually running it for like a real reason.
Yeah.
Debugging it.
Yeah, I can see that. Yeah, debugging it, I can definitely see that because you want to know if it changes. Was it because of the random number, or was it because of the something in my code? So yeah, good point. So and we can store random values and then print them. Just sort of showing here. And then let's say we wanted we can make a magic 8-ball. So here we have all of the values from a magic 8-ball. So we can store that as a list. So this is just a list of strings. If we can verify that by just typing that. And we can then use random choice to get a value. So let's say, will it rain this weekend? Oh, uh-oh. So Magic 8-Ball says it will rain. But depending on how we set the seed, we might get a different answer. So, okay, just a couple more things here before we finish. There's a number of ways to get help with commands. So, first thing we can do is we want to see all the variables in the workspace. We can type %whos, and that will print out all these different variables and modules. Now, if we had done, I'll just show you. If we did from math import everything, we just dramatically increased our workspace here, our namespace. So we have all these functions from math. So this is part of the reason why we don't like to do that, is you've now got all these extra things that you could accidentally have to deal with. And another thing, if the window gets too big, you can click on it to expand. Here, the IPython window, and I apologize, my screen is shrunk because I'm trying to make it visible to you. But if you want to then collapse that window, you just click on this margin here. In fact, it even brings up a menu that says click to scroll output or double click to hide. So I can click 1 to scroll, and then double click will hide everything. Okay. Now I just have put here that you can, so it says try typing S, and I put this in this notation here. Actually, if I'll show you another trick. So if I highlight this cell and type M, it'll convert it to Markdown format. And you can see that when I then execute it, it formats it as Markdown format. And then double clicking on it again. I think it's, what is the shortcut? Let me. Yeah, so Y would be code format and M would be markdown format. So Y, we'll turn it back to code, M markdown. So Y, what I had before was it was in code format, but just with a comment. That's another thing. So this pound sign or hash sign is a, or I think Zed calls it the octothorpe, is a special character that just says this is not code that I want to use. Maybe it's a comment, maybe it's just code that I don't want to use right now. So you put that there. So this is now a code cell, but it's just showing it as gray. Okay, so we can execute it. It doesn't do anything. It's just a comment. Okay, so now we've got this. It says try typing s dot and then tab to see which methods this string has. So I do that and I type tab and I get all these things that pop up. This actually is an option in the IPython interpreter or the command line interpreter for IPython as well. But so all these different methods that are available for strings. So this like upper one we can type. Now if I just type upper without anything else, it gives me this interesting output. It says function string upper. What I did was I just executed the method, but to actually make that method run, right now it's just telling me what it is. If I actually want it to do something, I have to type the parentheses. That's saying I'm not just getting information about it. I want to actually run it. So now when I do that, I will get it will actually work. So any kind of variable that you have, you can type it and a period and then tab and just put, the tab key is your best friend. You can autocomplete and also get all these auto suggestions. The same thing is true for modules or packages. So I can type math dot, and here's another reason why we don't want to do that from math import all import star, because the nice thing about doing just import math is that now we type math dot and we know all these are functions in the math package, and so it's nicely organized. This is called object-oriented programming. If you've ever heard this term object-oriented programming, C++ is one example. There's a lot of others. Python is another example. So you have an object. In this case, we had an object which is a string that's assigned to this variable s, and that object has these methods that are associated with it that we can use. So we can take a string and we can make it uppercase. Or we can take a string and we can say, is it alphanumeric? These are all methods that are attributes of this string thing. Similarly, math is a module that we imported, and it has attributes, which are various functions that we can do to things. And so the nice thing about this notation, and we use these periods between the different levels of things. You can actually have multiple levels in certain packages. You might have multiple levels where you can traverse down until you get to what you want. So these are all functions that are accessible from
Like if you import all math on, can you unimport it? Or
no, it's not very easy to unimport something.
you have to like clear all?
You can restart your kernel. It's the best way. So it's usually not a big deal if you import something that you don't need, but yeah, you can. The best way is just to restart your kernel.
Did you do something earlier where you were able to run everything up to the
Yes. So that's called under cell. So you can run cells would just be running whatever you're selected now, but this would be run all above. Or actually, typically what we do is run cell and select below. So that's when you hit shift enter. It's going to run that cell and then go to the next one. That's kind of the desired behavior. But yeah, you can run all above, or you can just run all. Also, this cell type is another way. So you can convert a cell to code format. These are mostly code here. You can also convert it to markdown format or raw NB convert. What this does is the cell looks like regular code, but it doesn't. It's not executable. So if we did this, it looks like code, but if I run it, it doesn't do anything. So this would be good if you didn't want to comment out the whole thing, but you wanted to leave it in there, and you can do that. So let's change that back to regular code. And so in addition, so we saw that you can type the name of the variable or the package and then type a period and then hit tab, and it will give you all these options. So with S we can type S dot and then it'll give us all these things. Capitalize is nice because it just capitalizes the first letter. And then, but you can also type S and then question mark, and it will give you this information about the object. So here, this S was a variable, so it says the type is string. The actual string itself is spam, has a length 4, and there's some additional information about that object here. We can also type S find and question mark and then hit shift enter, and it will bring up this information about find. Like, so we get we're going to find a substring contained within that, and there's some optional start and end arguments that we can use. This also works with if we wanted to do random. So another thing we can do is let's say I don't want to type out the whole name of the package random. I can just type rand tab, and then okay, I want seed, and I want to learn more about that. And so initialize the internal state from a hashable object, and there's information about seed there. So these are all super useful ways to get information about stuff that's in your namespace, whether they're variables or functions or modules. This is in addition to going to Google and saying like Python random seed behavior or something like that. And so, this would, for example, give you more information. Okay, I don't need that anymore. So now we're done. So when we're done, you can let me pull up. You guys don't need to toggle your menu bars if you don't want to. I'm doing it just to save screen space. You can save. You can type Command W, close, and you don't need to shut down these notebooks. You can just close the window, close the GitHub. Now you're going to go back to your terminal here, and it's going to say we closed the terminal within the Jupyter notebook, and we saved the lesson file. which is just located in the main folder. And then all you're going to do is type Control C. If you want to shut it down, type Y for yes, and it'll shut that down. And now we're good to go. If you're done with this environment, you can type source deactivate, and it'll exit out from your Python environment. All right, that's it for today. And next time, look at our schedule here. Next time we will cover taking input, reading files, writing files, and functions.